If f vector is a derivable vector function of the scalar variable t, then derivative of cross product of f vector and df by dt, this is equal to cross product of f vector with d square f by dt square. So here also we have to start from the left hand side. So let's see, d by dt of f vector cross df by dt, right? How can we take the derivative for the cross product of two vectors? Yes, again the same formula. First function, cross product with the d by dt of the second function. Then plus derivative of the first function with cross product with the second function, right? Okay, first function cross product with derivative of second function plus derivative of first function cross product with the second function. Easy? Alright. So this is equal to f vector cross, this can be written as, so this is d square over dt square and this is f vector plus, now cross product of the same vector is equal to 0. This we know that, and I have also written this in the remark in the previous videos, because this is equal to first vector mod second vector mod sine of the angle between these two, right? Because both these are the same vectors, so angle is 0 and sine of 0 is 0, so this is equal to 0. The cross product is 0. So we get f vector cross d square f over dt square. Hence the result that d by dt of cross product of f with df by dt is equal to f vector cross d square f over dt square. That means first vector as it is and its cross product with the derivative of the second vector function, right? That is d by dt of df by dt, which is d square f by dt square, right? Okay. Now comes the topic geometrical significance of df by dt, where r is taken to be as function, vector function, which is depending upon the scalar variable t, right? Now let r is equal to ft. This is be a single valued continuous vector function of a scalar variable t and with o as origin. You can look at the figure. This is the origin o and I have taken a point P whose distance is r vector and another point Q whose distance from 0 is r vector plus delta r vector, where delta r is a change in r vector, right? A slight change in r vector. Now let OP vector is equal to r vector for a certain value of t, and let OQ vector is equal to r vector plus delta r vector corresponding to the value t plus delta t. If there is a slight change in delta r, then obviously there is also a slight change in delta t, right? Because r is depending upon the variable t. So where delta t is a small increment in t, if suppose this is t, if I get a small increment in t, then this will become t plus delta t, alright? Now let's check the value for the PQ vector, what it comes. So this OP vector is equal to, this is r vector, which is ft. Fine, take this as your 1. And OQ vector is r vector plus delta r vector this is equal to, yes, if r vector is equal to ft, then r plus delta r vector is equal to f of t plus delta t. Very good. So take this as your 2. Now PQ vector is equal to what? Do you know about the triangular law? This PQ vector, this is OP vector. Sorry, this is your PQ vector. This is equal to sum of these two sides. That is PO vector and OQ vector. So I am writing this side plus this side. This PQ having the arrow upper side is equal to, I am taking PO plus OQ, right? So this is PO vector plus OQ vector, which is a triangular law. I am writing OQ first. And instead of PO vector, I am writing minus OP vector because I am having the value for OP is equal to R. I am having the value of OP as equal to R. So I need to change this. Now writing OQ as R vector plus delta R vector. OP vector is R. So R and R cancel. So this is equal to delta R. So that means by PQ vector is nothing but delta R. So this is delta R vector. That is a slight increment in R, right? So this increment delta R is equal to the vector PQ. Hence, delta R by delta T is a vector parallel to the chord PQ. We say that the slight change in R with respect to the slight change in T. This is a vector parallel to the chord PQ, right? And if I take my delta T tending to 0, then this Q point will approach P, right? As delta T is tending to 0, because delta R is depending upon T, the scalar variable. As delta T is tending to 0, that means delta R is also decreasing. And we get this Q point to be tending to this P point, right? So letting delta T tending to 0, we have limit delta T tending to 0 on delta R over delta T. This will be equal to your dR by dt. That is derivative of R with respect to T, which is a vector parallel to the tangent at P. So you have to remember that if we are talking about the slight change in R with respect to slight changes delta, if we are talking about the slight change in delta R with respect to the slight change in delta T, then this is a vector parallel to the chord PQ. And if my delta T is tending to 0, then that will be equal to, if I limit my delta T tending to 0 on del R by delta T, delta R over delta T, then this will become dI by dt. That means a derivative of R with respect to T. Then the final vector will be parallel to the tangent at P. See, Q will be tending to P. So now this will become your tangent at P. So this tangent is this dr by dt is the vector parallel to this tangent, right, at P. As delta t tending to 0, which implies Q is tending to P, which implies the chord PQ becomes tangent at P. See, this chord PQ will become tangent at this P. Is it clear? This is just a simple geometrical significance of df by dt, where we have taken R to be as ft. So next time we will be doing some concepts upon differential operators and velocity and acceleration, right? So this concept is need to be discussed here. So thank you for watching this video. We will meet in the next video.